Good evening. So, in the last week, we studied about the variants of advances in gas metal arc welding and the shielded metal arc welding and flux core arc welding. So, today's today we will study about the submerged arc welding and resistance welding classifications. So, first start with the submerged arc welding. So the submerged arc welding in which the uh, arc is shielded by some flux that is also in means coarse granular flux is used to shield the arc. So according to this diagram, we can see that the this is the contact tube and providing filler wire, and with that flux hopper is provided to feed the flux around the arc. So, well, this flux helps in the protection of arc from the environment to reduce the heat losses. So, the mechanism that deals with mechanism that is very required in submerged arc welding is that the heat transfer efficiency. Is the heat transfer efficiency. So, if we recall the heat generated at the anode, formula can be written as the VAI plus CA V column I plus IAI plus 3 by 2 K T column minus TC cathode divided by E and I. So in this term, the all terms are in this heat generated equation, the all terms are positive. And here the Ca term, which represents the heat transferred from the column to the anode. This anode is the workpiece in this case. So Ca is the fraction of energy or heat of arc column transferred to the anode, and the efficiency can be written as for a um, for a consumable arc welding is written as QA plus QC divided by 2. So the this heat generated at the anode is protected by the this flux. So the heat losses are minimized. So heat losses are minimized by using the flux, and as the heat loss is minimum and the all so the heat transfer efficiency of this the efficiency of submerged arc welding is approximate to 100%. Means it is greater than the gas metal arc welding process. So that's why it is the submerged arc welding is superior to the gas metal arc welding. On the characteristics of this submerged arc welding are first is the high deposition rates, because the electrode means filler wire dia means filler wire dia is very high in this submerged arc welding process, greater than the gas metal arc welding filler. The second characteristic of this is the no visible arc radiation. Means it is environmental friendly. Means there is no escape of the radiation from the welding position. No visible arc radiation. So this submerged arc welding is also safe. Third point is it is difficult to use positionally. Positionally means we cannot use it vertically or overhead in overhead welding, because then the protection provided from the flux will not work. So only flat welding can be done in submerged arc welding. Fourth point is It is normally used for thickness greater than 6 mm. Means the thicker sections can be easily welded in submerged arc welding. Next is the resistance arc welding. So the basic principle of resistance arc welding to generate the heat is joule heating. And the joule heating can be written as uh, Q equals to IV, means this is the power term for a time, this is time t. And we know that V equals to IR. So Q can be further written as I square RT. So if we want to calculate the unit, so the I has ampere, current unit is ampere, voltage unit is volt, and T is second. That will lead to the joule. So and Q is written as the energy per unit time. Energy generated per unit time means power. I is the current in ampere. V is voltage and volts. R is resistance. The unit of this is ohm, and T is the time in seconds. So this is the schematic of the resistance welding, and this is generally for the resistance spot welding. So the resistance in this resistance spot arc welding comes with the contact resistance of the two joining plates. So the R is generally the contact resistance between plates. So but there are other more resistance or other resistance also of the electrode and working plates. But the resistance of that means electrode and the plate should be less than the contact resistance to generate the heat at the to form the spot weld spot. So for that is in this schematic, if we see, means this is the water cooled copper electrode. So cooling is provided, means there is some contact resistance between the electrode and the welding plates also. So that's why some heat will also generate here at this interface. To remove the that heat, we use the water cooling mechanism. and the whole setup is connected to the AC power source. So this at the left hand side, the welding temperature according to the interface and material is drawn. So the at the so R1 is the first electrode resistance, R2 is the resistance at the electrode and plate uh, interface, R3 is the R3 and R5 here is the bulk resistance of these plates. R4 is the contact resistance between these two plates. And the R6 will be contact resistance between the second electrode and plate. And R7 is the bulk resistance of the electrode. So all resistance should be less than the contact resistance between these two plates. So only then the heat generated will be maximum at the contact of plates. Then the when the force is applied during the welding, so that will lead to the formation of a nugget, means weld nugget. So this this is called as the weld sport or nugget. So there are variants of different variants of the resistance spot welding. So resistance welding. So first is the resistance spot welding, RSW. So means only one spot is uh, one welding spot is created. Next is the resistance seam welding. It is written as RSEW. Seam is means the two plates are joined and the uh, electrode as electrode is moved uh, through this joint continuously, means the continue it is also called as means continuous spot creation welding, means the continuous weld joint is formed in this resistance seam welding. And the resistance in welding can be also divided in two types. First is with high frequency. Hence, RSEW, high HF. And second type is the with induction heating. The third type is the projection welding. Fourth is flash butt welding. So in both projection and flash butt, the arc is generated between the plates. And then that arc melts the plate interface, and then the force is applied uh, to form the joint. Fifth welding is the upset welding. In upset welding, the heat is generated to the point on that only plates reaches to the melting point to the are softened. In means upset welding, the plates are softened for at higher temperature. Then by using the upset force, the welding joint create and forming an upset. That's why it's called the. These are two plates. So this type of welding joint form in this upset welding. That's why it is called upset welding. The upset welding can also be divided in two types. Means upset welding with high frequency within second is with induction heating. UWI. The last resistance welding type is the uh, percussion welding. So today we will discuss about the spot welding. So the resistance spot welding schematic is this is same. Uh, so this is the welding spot generated in resistance spot welding, and the resistance and temperature variation according to the um, electrode and plates interface and the bulk resistance is drawn into this diagram. So the resistance is also higher at the electrode and working plate interface. Then it decreases in the plates. Then at the contact between two plates, the resistance is highest. So the temperature generated at the contact means the welding interface follows the same rule as the resistance means it is high. The temperature is highest at the interface between two plates. So this is the diagram of the welding joint formed between two plates. So this is for upper electrode, this is lower electrode. So in this case, we need the high conductivity copper electrodes. Means high thermal and electrical. High thermal conductivity and also low resistance. The contact resistance between the two plates depends on first the roughness and condition means how we can maximize the resistance at the two interfaces of the plates. So this depends on the roughness, condition, and pressure applied on the plates. So in this case, it is R4. So R4 is the contact resistance. So it depends on thickness, roughness, and force applied. So as the surface roughness is high, resistance will be maximum, and if and the resistance is inversely proportional to the force applied, means for lower force the resistance will be high. And here the welding joint created. So the size of the welding joint also depends on the welding current, resistance, thickness, and so size of welding joint. It depends on thickness, resistance of the plate or at the contact, current, welding time, and load. So the Q heat generated can be written as I square R4 T. R4 is the contact resistance between the plates. So the means this is the diagram of the current and force with time. So for a 1.2 mm thickness plate, uh, the current applied is around 5.5 and the force is 3.5. So first force is increased and the current is applied of the 5.5 kilo ampere for a time. Then when the current is decreased, force is remain constant for some time to to cool and solidify of the molten metal at the interface and forming the welding joint. So this process happen just only takes the around 340 milliseconds. So this means this is very fast process. And the characteristic of this RSW are the it mostly uses AC currents at 10 raised to power 2 to 5 ampere, but sometimes DC. DC can also be used. The contact resistance determines contact resistance R determines heat generation, and R is the inversely proportional to the electrode pressure. The heating and cooling rates in this uh, resistance spot welding can go as high as 10 raised to power 3 Kelvin per second. Go as high as 10 raised to power 3 Kelvin per second. And generally, the welding configuration is lap joint. For a 1 point. So, and the thickness of the plates are also mostly 1.2 mm. So, if we want to calculate the uh, means heat input or the time required means the heat input required for a specific application and the temperature gradient. Yeah, means the heating cooling rates can go as high as 10 to power 3 Kelvin per second. So these high cooling rates further determine the microstructure developed microstructure of the welded joint. So if we want to uh, calculate the temperature gradient for a residence spot welding process, means this is a material, and if we increase the temperature from 300 Kelvin to 1800 Kelvin, so the heat means the delta T can be calculated as this. And if we talk about the physics of this temperature gradient, then heat is generally written as mCp delta T, where m is the mass, Cp is the heat capacity, and delta T is the temperature gradient. So the temperature gradient delta T can be calculated as Q divided mCp. And as we know that the heat Q generated in the resistance welding is I square R full T. So then the temperature gradient will be I square R full T divided mCp. So heat capacity for a material we know, and mass can be calculated as the density of the plates and the volume welding joint volume. So generally the welding joint is formed in a cylinder shape, cylindrical shape. So the volume of this is written as pi r square h. So h is the uh, thickness of the two plates. R is the contact area between the electrode and workpiece, and density of the material we know. So we can calculate the M, mass of the welding joint, and according to that we can calculate the temperature gradient of the welding joint formed. So this is the weld cycle of the resistance spot welding is shown in this schematic. So for first the electrode force is increased to a level, then it is maintained when the welding current is applied. So this time is known as the squeeze time. Then the weld time, during this the current is applied. Then the hold time to make the joint at the contacts, and after that the current goes to zero, and the electrode force are also decreased. So this is the whole time is to solidify the spot joint, and for some time the off time is given between the second welding joint. So
Yeah, good evening, ma'am.
good evening. Are you able to see my screen?
Yes, ma'am.
Yeah. So today I will I'm going I was teaching the means in the last week we studied about the gas metal arc welding advances, and shielded metal arc welding and flux core arc welding. So today's class is on the submerged arc welding and resistance spot welding. No, only resist means variation of the resistance welding. So I was
Okay, ma'am. Ma'am, we have covered this GPAW, gas tungsten arc welding.
gas tungsten
Have
arc
you
welding is
already
completed
covered?
in previous lectures.
Okay, okay, okay.
So you can go through the recordings, previous recordings.
Yes, yes, ma'am. I will.
Okay. So just I will give start from the beginning. So this is the means submerged arc welding schematic of the submerged arc welding. So in the submerged arc welding, the basic principle is that the heat transfer efficiency of the submerged arc welding is very high, means highest in from the any welding process. So in this submerged arc welding, the arc generated between the filler wire and the welding joint is protected by the granular flux fed from this flux hooper. So the covered flux means prevent the heat losses and radiation, heat losses from the conduction, convection, or radiation, and the so the means the almost 100% of energy is used in the welding process. So if we talk about the heat generated between the filler wire and the workpiece, and so the workpiece here is the anode. So means anode or this filler wire. So the heat generated, this equation we know from the previous lectures. So it can be written as the VAI CA V column I plus pi A I. This is the work function term, and plus 3 by 2 K T column minus T cathode multiplied by I and divided by E. So this term comes from the heat generated at the anode only. This comes from the heat transferred from the column to the anode, and this is the work function, and this is the heat transferred by the electrons coming from cathode. So this, if we means talk about this term, C means the heat transferred from the arc column to the workpiece. So the term Ca is the fraction of energy or heat of arc column transferred to the anode, and the heat transfer efficiency for this process can be written as the Qa plus Qc divided by 2. So the heat transfer efficiency of this submerged arc welding is approximately equal to 100%. So that's why the submerged arc welding is more beneficial than the gas metal arc welding.
Ma'am, here in this expression 3 by 2 K, what
Yes,
is K? Is it thermal
K is
conductivity?
the Boltzmann constant.
So it is radiation related term.
No, no, it is the means kinetic energy of the electrons transferred to the anode.
So what will be the value of K? That's
K
decimal
is
Boltzmann
the
constant.
Boltzmann constant, so around 1.38 into 10 raised to power minus 3, means 10 raised to power minus 5, or it depends on the unit of the QA. If it is in joule or in a volt term, it is the K is generally written as 1.38 into 10 raised to power minus 5, or means volt per Kelvin,
Okay.
electron volt per Kelvin. So the characteristic of submerged arc welding is are the means the high deposition rates can be achieved in this, means, and because of the filler wire used in this submerged arc welding is very thicker as compared to the gas metal arc welding filler. And the second point is that the no visible arc radiation, means the arc is protected by the flux, so there will be no radiation coming out from the welding joint or arc. The and is next point is that it is difficult to use positionally, means we cannot do the vertical welding and overhead welding, because in that condition the flux protection we cannot provide that flux protection, so only flat welding can be done uh, by the submerged arc welding. Then it is normally used for thickness greater than 6 mm, means higher thickness, thicker section can be easily welded. So next is the resistance arc welding. So the basic principle of resistance arc welding is the joule heating. So the joule heating term can be written as the this formula: Q heat generated by the current, voltage, and time. And here IV is the power, and we know that the voltage and one more thing is that the voltage cannot be calculated directly. Only we generally know the current value. So we calculate the voltage from this equation V equals to IR. So if we put this term in this, so Q equals to I square RT. So the current supplied T is time, and due to the resistance of the welding workpiece, the heat generates in the during the welding process. So Q is written as the energy per unit time or power. I is the current. V current in ampere. V is voltage. R resistance in ohm, and T is time. So in this case, what is which resistance we are considering? Means this is the schematic of the resistance spot welding. So this 1 or 2 is the copper electrodes, or these electrodes are also water cooled from the inside. So there are many resistance uh, coming in this picture. Means first resistance is the electrode resistance, but it is copper electrode, so the resistivity of the copper is very less. And the next resistance come in by the contact between the electrode and the plate, which is R2. Then the R3 and R5 is the bulk resistance of the these plates. The R4 is the contact resistance between these two welding plates, and similarly the R6 is the contact resistance between the plate and the electrode, and R7 is the resistance of the electrode. So here the contributing resistance term is from the resistance of the uh, two plates, welding plates. So only we will consider the R4. Means in the left side the welding temperature profile is drawn according to the resistance. So at the electrode and plate contact, the resistance is also high, so it will the temperature will also increase at this interface. So that's why these electrodes are water cooled continuously. And as the resistance is highest at the contact interface between these plates, so the temperature will be highest highest here. So that will lead to the formation of the weld spot or nugget. Means, and also the shape of the welding spot is in this resistance spot welding is the cylindrical shape. So the resistance is the contact resistance between the plates here. So if we classify the resistance welding, so first come,
Excuse me.
yes.
If the thickness of these two plates, suppose the upper plate is thicker than the lower plate,
Hmm.
will be there any variation in this
Yes, ma'am. The means
setup?
the welding joint will be dissimilar.
No,
Generally,
but
we'll
in the
prefer the same thickness plates, because then the
okay,
strength will be low for that case if we use the dissimilar thickness.
okay.
So the resistance welding is classified in first is the resistance spot welding. So resistance spot welding is the this schematic only. So single welding joints are created in the first resistance spot welding. Next is the uh, resistance seam welding. So it is written as RSEW. So in resistance seam welding, two types of welding is there. So RSEW with high frequency. Mhm. And second is the means heating is by induction. So RSEW with induction heating. So the see two types of resistance seam welding are there. So the seam welding is that means these two plates are keeping in contact, and the electrode is moved to the this interface of the two plates continuously. Means the continuous spot welding happens in this case, second case. So that's why it is called the seam welding. Next is the projection welding and flash butt welding. So projection welding and flash butt welding are in these welding. The first the arc is generated between the means between the working plates. Then due to the arc, the working plate the at the contact working plate will melt, and after as the uh, well metal molten metal is squeezed further, forming the welding joint. So in this first arc is generated, followed by applying force. Next welding is the upset welding. So it is also divided into two types, means upset welding with high frequency and upset welding with induction heating. So in this upset welding, two cylindrical rods are first squeezed. Then due to the squeezing, the the at the contact the metal will get so means the metal softens, and the softened metal was will further means the force will increase between these two cylindrical rods to form the welding joint. So the welding joint form is looks like this, means it is coming outside the cross sectional area of the cylindrical rods. That's why it is called the upset welding. Means the shape of this is as the upset. The next welding is the percussion welding, in which some rotating arm is used to apply the electrode force. So first we will discuss the resistance spot welding. So the schematic of this resistance spot welding and mechanism is the same uh, uh, according to this schematic. And if we talk about the resistance and temperature variation according to these welding joint and electrode plate interface. So at the interfaces of the electrode and plates, and the resistance between the two plates is the highest, and similarly the temperature will be higher for the contact between two plates. And this is the geometry of the welding joint in the resistance spot welding. And generally the lap welding joint formed is called the lap joint, because the one plate is um, put on the second plate, so this position is known as the lap joint. So in the uh, so the high conductivity copper electrodes are used for the resistance welding. Also, the resistivity of the copper electrodes are also very low. So here only we consider only the contact resistance R4 between the plates. The contact resistance means how can we increase or decrease the heat required or heat generated to form the welding joint. So it depends on the roughness of the plates and the force applied. So if the roughness of the plates will be high, so that will result in the increase in resistance, and the generation will be high for a given current. And the resistance is inversely proportional to the force. Means for low force applied, the resistance will be high and the heat generation will also be higher for that case. And next is the means size of welding joint also depends on the thickness of the two plates and resistance between the two plates, current, welding time, and load. So the heat generation term can be written as the I square R4T. And this diagram is so at this side the diagram is for the 1.2 mm thickness plate spot welding. So for this case, the 5.5 kilo ampere current is supplied between the electrode and working plates, and the force of 3.5 kilonewton is applied. After that the current is supplied. So for a working period up to 250 millisecond. After that the force decreased, and the no current is decreased, but the force is applied to a longer duration to for cooling and solidifying of the welding joint. So this process generally happens in the means the one spot weld create in around 340 milliseconds. So it is very fast process. So the characteristic of the resistance spot welding is the means the current uses are the AC current, means it uses mostly AC current of 10 raised to power 2 to 10 raised to power 5 ampere, but sometimes DC also used. The contact resistance R determines the heat generation, and the resistance will further depends on the composition of the two plates also. And the resistance is inversely proportional to the electrode pressure. The heating and cooling rates of in the resistance spot welding can go as high as the 10 to the power 3 Kelvin per second. So this high cooling and heating rates further affect the microstructure of the welding joint. So, and the welding configuration is in the spot welding is no, called as lap joint. So to as the means heating and cooling rates are very high, so if we want to uh, further modify or alter uh, the heating and cooling rate, so first we need to know the temperature gradient of the welding joint at the welding joint. So if we consider a material A and we heat the material, we want to heat the material from 300 Kelvin to 1800 Kelvin. So so if we want to calculate the temperature gradient between at, at the welding joint, so the heat can also be written as this formula is mCp delta T. So here m is the mass, Cp is the heat capacity, and delta T is the temperature gradient of at the welding joint. So delta T can be written as the Q by mCp, and Q is in this resistance welding is written as I square R4T. So further than this temperature gradient can be easily calculated by this formula. So in this the m mass m is the mass of the welding joint. So generally the welding nugget forms in the cylindrical shape. Means these are the two plates, and this is the electrode. So the welding joint formed like in this shape. So this is uh, the shape of this is the cylinder type. So we can easily calculate the volume of the cylinder by pi r square h. H is the total thickness of these two plates. This is H, and R is the contact area between the electrode and the plate. This dia. So R will be d by 2, and from by multiplying the density of the plates and the volume, we can calculate the mass of the welding joint, and from that we can calculate the temperature gradient in the welding joint. So this is the weld cycle for a resistance spot welding process. So first in the squeeze time, the electrode force is increased to hold the two plates together. Then the current is supplied during the weld time to heat the metal at the contact. Then after heating, the force is maintained for some time, that is called the hold time, to cool and solidify the welding joint. Then so this and after some the off time is also provided. So this means squeeze time, weld time forms the one welding cycle, and this cycle is followed further for more spots joint. So the weld cycle enhanced for this resistance spot welding can be shown by this picture. So in this the squeeze time, yeah, and so this is the and we can also calculate the weld nugget diameter using the thickness of the welding plates. So welded nugget diameter is written as 4 times square root of thickness. So if we use a 1 mm thickness plate, so the welding joint will created as the 4 mm dia.
Is it a thumb rule or is there any mathematical or some
Yeah, it
concept?
is the thumb rule used in this welding.
So it's an empirical relation, this is, no?
Yes. Yes, so sometimes this welding cycle is also controlled by a PID controller. So means PID represents the professional integration and differentiation. So this PID controller is used for this welding cycle to further enhance the welding process. So here the welding cycle is further divided into many parts. So first is the uh, squeeze time. So the this in squeeze time, the pre pre-compression force is used to set the electrodes and workpiece together. So this is used to hold the electrode and and workpiece together. So this force is generally called as the pre-compression. The second part, the means the uh, plates are preheated. So this preheat is provide to reduce the thermal gradients at the start of weld time or to soften the coatings. That means if we are using some steel, so there is also there are chances to that means galvanized steel coating. So the preheat time is used to soften the coating of the plate and to reduce the thermal gradient. Gradient is reduced in the preheat time. Means only a small amplitude current wave is supplied in this preheat time period. Next is the upslope time. So here the force is maximum force is applied in this condition, means the current is increased. So in the preheat time, the pulse means frequency is less and current is amplitude mean. Yeah, frequency is less and current amplitude is also less. In after that, the frequency also increased with increasing the current amplitude. So this is applied to heat the material up to the melting point, and the forging force is yes, and the force is also maintained for this time period, and that is called as the forge delay time. So this forging force is used to help consolidate the weld nugget. means this forging force used to consolidate welding nugget. Then the current is decreased after the melting of the workpiece and consolidation. So this small cool time is provided to uh, reduce the melting. Means if continuous melting happens, then we cannot form the good spot weld. So that's why the cool time is provided between the welding process. Then in the downslope time, the current is decreased and the force is further increased. So this force is also used to consolidate and solidify the welding nugget uh, uniformly. And after that, and during the forging force application, the quench time is given when the current is zero. So this quench time and further the temper time, these times are given to produce desired weld properties in hardenable steels. Means here the quench time is given, so the all welding material, means the welding joint material will get cooled. Then after, as there are some thermal gradients are there during the welding, so to because of that thermal gradients, there will be variation. Will be variation in the microstructure. To to form the homogeneous microstructure, we do tempering also during the welding only. So the low amplitude current wave is applied to provide the heat during the temper time. Means tempering is done for the steels. This tempering is done at low temperature to modify the microstructure, modify welding microstructure. Then further that welding joint is hold for some time when the during that the force is uh, decreased to zero. So this is the whole completed, means in enhanced weld cycle to form the uniform homogeneous welding joint. So what is the means variation in the when the thermal temperature gradient is high and low? So at high temperature thermal gradients, columnar grains form, and also the alloying elements segregate at the interface, at welding interface. So because of this segregation of alloying elements, there the welding interface region will become brittle. Means the strength of the welding joint is less, and so To remove this effect, the quenching and tempering is done. And here in this case, where the current is decreasing, so this current is also helpful in the aluminum alloys welding, to prevent the cracking. Means weld cracking can also be uh, uh, avoided by decreasing this current by some value, mm, by some rate. So this is the a schematic of the single phase AC spot welding circuit. So this is the AC welding source. This horn arm is used to hold this cantilever beam, and so all the elements in this circuit are good conductors. And this is the electrode, and the workpiece is held between these two electrodes. Mm, So one more thing is that, so the current and the welding time, also further defines the welding joint strength. So generally the shear strength is coming because if we see the welding joint between two plates, so these are the two plates, and the welding joint is formed as this. Means at this point the welding joint is there, but due to some separation after this nugget, and the this configuration forms a notch. So this notch is very detrimental to the strength of this welding joint. So the current and weld time, to provide the uniform welding joint, depends means, and to further determines the shear strength of the welding joint. So with increasing current, yeah, yeah. So the nugget diameter uh, can be modified by varying the current or the welding time. So either we can vary the current, or by fixing the current we can vary the welding time. So the this is graph, this plot is between the uh, current to time and the nugget diameter. So the nugget diameter follows this rule. Means nugget diameter increases with the current supplied and the current welding time. So at this point, the maximum welding nugget diameter we can achieve, maximum diameter, and the value at which the maximum diameter can be achieved is written as I max. So after the I max, means if current is increased, so that will in means further melt the welding joint, leading to the expulsion or splashing. Means the molten metal available at the welding joint is in high amount, so the expulsion and splashing of that molten metal will happen if we increase the current above the I max. Yeah, so this is the thumb rule to get the nugget diameter is the 4 times square root of the thickness of welding plates. Sometimes the 4.2 or 4.1 is also used for different applications here. So if we consider the shear strength versus current, so with increasing current, the welding nugget diameter increases. That results in increasing shear strength of the welding joint. And after that point, when I max reached, expulsion begins. That decreases the shear strength of the that welding joint. And the variation between the shear strength and time is explained in this second plot. So with increasing the welding time, shear strength means the nugget diameter increases, so the shear strength will also increase uh, up to this point. And after some time, the uh, shear strength will get means it will not vary much, and it will reaches to a saturation value. Means this is the maximum shear strength we can achieve with the weld time. So the optimum shear strength comes in this region. So this also depends on the welding material and the current supplied. So further, if we talk about the temperature gradient in the welding joint, so the blue are the copper electrodes, because and the copper electrodes are water cooled from the, these positions. So that's why the electrodes are at the lower temperature. But at the interface between two plates, the temperature is highest. That will decrease very steeply, means there is very steep gradient from the interface to the uh, working plate and electrode surface. Means we can see that the in this case, in this condition is of the molten, and after that the temperature is decreasing very sharply. Further, the temperature at the weld center or weld edge with varying the time can be shown are shown in this graph. So temperature versus time this time is in millisecond. So the red line is for weld center, means weld center temperature is high for a certain time, and weld edge temperature is always lesser than the weld center temperature. So for this time when welding occur, the weld center temperature is around uh, 2000 Kelvin, and the means the weld edge temperature is around 1800 Kelvin. So with the time when the welding process start and finish, so the temperature will decrease after each cycle. And this is the schematic representing the temperature profile of the metal and the electrode. So the electrodes are water cooled, and this is the weld nugget formed between the interface of the these welding plates. So the uh, means this is the welding joint, and this is interface. So the columnar grains form like this pattern. So the alloying elements generally segregate at this interface and between these columnar grains also. So the and that region will become brittle because of the segregation of the alloying elements. And the welding temp this high temperature gradient also helps in minimizing the heat affected zone. Means in this previous slide picture also we can see that the means heat affected zone in the spot welding is very less. So the one advantage of the steep thermal gradient is that means the heat affected zone is very less, but it only affects the welding joint microstructure. So that can be further um, modified by providing some heat treatment to the welding joint. So this is the microstructure formed in the this but spot welding. So this is the weld nugget formed. This and the microstructure in this we can see the small columnar grains are forming in the weld nugget. Next are the electrodes used in the this resistance spot welding are generally of six types. So type A pointed means the different geometries are used for the spot welding. So generally the type E truncated and type A pointed electrodes are uh, preferred for the means they are mostly used because with the welding process also with time the and there is some means resistance at the electrode and workpiece. Workpiece resistance will generate some heat. So because of this heat, means the almost heat is dissipated by the water cooling mechanism, but with time the electrodes also start getting flattened. Means the truncated and pointed tips are used to increase the shelf life of the electrodes. If we use uh, the radius or flat type electrodes, so the shelf life of those electrodes will be less. So with the welding process, welding service life, the contact area of electrodes it increase because this generation of heat. So that's why these pointed and truncated shape electrodes are used. And the standard of this electrode is the ISO 5182. This is used for the resistance spot welding electrodes. And we know that these electrodes are made of copper, means copper and copper alloys are used. So sometimes the stainless steel or the galvanized steel have zinc coating on that. So the zinc can also diffuse to the copper electrode with time. So because of this diffusion, the copper composition will change and form the uh, brass, means copper and zinc alloy is known as the brass. So this happens because of the zinc diffuses to copper electrode with time. So this alteration of the composition of the copper electrode also changes the resistivity of the, means the thermal and electrical conductivity of the copper will decrease with time. Further, the application of this resistance spot welding is generally found in the automobile sector, means this is some automobile body. So around the average car body contains around 2000 to 5000 spot welds. So here in this case, we can see the black spots with the line. So these are all the resistance spot welded joints. And the 150 million welds are made every day in European auto industry. So in the worldwide only, the crores of spot welding joints are formed in a day. So the, means the application of this spot is resistance spot welding is very vast.
Excuse me,
Yes.
ma'am. In this strainer, there is sport welding strainer, which is kitchen strainer. I'm talking about छलनी जो रहती है ना
हाँ हाँ.
strainer.
Okay,
So
yeah, that big chalni.
yeah. So is there sport welding to join these wires
Yeah, sometimes
or
spot welding or sometimes the hammering also, means the hammering joints are also formed, and that
and
spot welding.
specifically
Yes.
मतलब बर्तन वगैरह धो के जब अपन रखते हैं ना जिस
हम्म,
छीका जिसको बोलते हैं हम
हाँ
हिंदी में एक बड़ा सा जो रहता है ना जिस कंटेनर टाइप
हाँ हाँ
जिसमें केवल वायर का ही बना रहता है वो राइट
हाँ.
वो भी स्पॉट वेल्डिंग है या कोई और कोई
नहीं,
उसको ज्वाइन कर
वो कुछ दूसरी वेल्डिंग है, वो आर्क वेल्डिंग से हम ज्वाइन कर वेल्डिंग करते हैं उसमें.
हम आर्क वेल्डिंग तो नहीं है मैम वो जॉइंट
सिंपल.
अब आर्क में तो अपने को एक अलग सा वो दिख जाता है उसमें
No, but the spot welding generally happens between flat plates, and उसमें जो रहता है छीका उसमें नहीं होता फ्लैट.
हाँ वो तो कर्व्ड पार्ट है यस कर्व्ड पार्ट है नहीं मैं ये सोच रहा था कि इज इट पॉसिबल कि जो करंट की सप्लाई है वो दे दी जाए एंड एट द सेम टाइम प्रेशर इज अप्लाइड ऑन इट
हाँ.
वरना तो इतने इतने सारे जॉइंट होते हैं इट इज वेरी टाइम टेकिंग एक्चुअली
Yes,
सो
but
कौन
it
सा
is
which method is basically used for joining these
uh,
आप समझ रहे हो ना देयर आर सो मेनी वायर्स
हाँ.
so
Yes, I
many cross
understand.
sections are there तो यदि आप
So for
लाइक
that,
वो
the arc welding is commonly used. I mean, generally the that oxyacetylene welding, in which oxygen and acetylene gas is used to weld
गैस
the
वेल्डिंग,
gas
गैस
welding.
वेल्डिंग।
Hmm.
ओके।
So for general purpose, the gas welding is very used.
हम्म। ओके।
Means the spot welding is generally used for high-end application. For the common purposes, the gas welding is used. So this is the graph between the common alloys welded with the resistive spot welding. So this graph is between the welding time and secondary weld current in kilo ampere. So the three materials are shown in this diagram. So the circle, the um, means the empty circle is for the mild steel, filled circle is for hot dip iron zinc alloy steel, and the triangle is for zinc coated steel. So in this graph, the welding time and welding current characteristic of the different uh, uh, steels in which the coating is varied is shown. So for the mild steel where no coating is applied on the plates, so this for this the means this single lined single line area is for this mild steel. So means the welding time and weld current is also less for this mild steel, because do we do not need to soften the coating. And as the coating is enhanced, means this is for the iron zinc coating. So for this, the welding time and current is increased further. Means the checked area is for the iron zinc alloy coated steel, and for the galvanized steel, we need very means increased welding time and welding current. So with variation in the coating or coating strength, the welding time and welding current also increases. So next is the weldability is shown. Can you see, or it is not visible? Means
Yes, ma'am. I can see it.
so it is means this table is given for different materials welding. Means this is dissimilar metals is used to weld by spot welding. So the ranking according to the welding joint created is given for like for alum, uh, aluminum, the spot welding is good, but the aluminum steel cannot be welded by this resistance, sorry, uh, resistance spot welding. And so similarly for other metals also, means the steel can be welded very easily. Means the stainless steel have the A ranking. Means the excellent spot welding uh, can be done with steels. And for similarly for other alloys, the ranking varies depending on the means uh, joint strength. So this table is for the means if you want to join the two similar or dissimilar metals, so we can refer this table for our purpose. Means it is for almost all metals. Means nickel, silver, zinc, tin plate, nichrome, nickel, monel, steel, lead alloys, galvanized iron, copper, brass, aluminum, and steel. So next is the welding joint geometry. Means this is the geometry of the uh, spot welding or nugget. So we will generally need to do spot welding. So this is the lap created between the two plates, and between means at the center of this length, we generally prefer to make the welding joint, and the distance between two spot is also very crucial. Means we have to maintain the this distance between two spot. If we weld the uh, spot very near to each other, so in this first case, means the welding joint is created already, and if we join the means second form this second uh, joint near to this, so due to this contact, the current will be very easy to flow, and that will not provide the uh, means the required amount of heat, because the resistance got increased between because of this very uh, less distance between two weld joints. So the required heat generation will be difficult. If we reduce the we reduce the joint to joint distance. So this rule we have to follow, means we need to do the welding at the L/2 distance, L/2 gap, and the distance between two joints also should be maintained. So the minimum spacing and minimum overlap for the according to the material thickness is given for the this low carbon steel. So with increasing the so with increasing the thickness of the uh, plate, this minimum weld spacing is also increasing, and the minimum overlap material also increases. So with increasing thickness, we have to increase the minimum overlap and the minimum weld spacing to form the good joints. So next is the shape of the means position of the shape and position of the this is spot the spot on nugget. So in the first case, only at the one side the spot are formed, but in the second case, the welding joints are created alternative to the both sides. So the second case will provide the maximum strength of the joint. So A is not recommended. And the second welding geometry is means this results in the balanced force and minimum distortion to the welding plates. And so this geometry is generally preferred. And the next is the this different welding configurations that is required for the resistance spot welding. So with this case means this angle less than 60 degree is not recommended. 60 to 80 degree angle between uh, this joint, this plate and this joint is feasible, but the recommended joint geometry is should be this means this there should be 90-degree angle. Similarly, for this the for creating the good welding strength, the distance of this two curved shapes should be increased. So in the second case also, next case means the C shape height with increase. So the welding joint will be good for this uh, higher gap between this C shape. Similarly, for this also, the with means this height is should be reduced to get the proper welding joint. Yeah, so the resistance spot welding is completed. So in the next lecture, we will study the resistance seam welding. So I have prepared some the assignment questions also. So do you have any
Yes,
doubt
ma'am.
up to this point?
No, ma'am. No doubt yet.
Okay, so we can go to the assignment questions. So the first question says that the submerged arc welding is suitable only for vertical overhead, flat or inclined position.
Flat should be the answer. है ना?
Yes. Second question is that the type of electrode used in submerged arc welding is
Bare wire, ma'am.
yes. The third question is the weld time and resistance welding depends on
All of the above.
no. The second
No?
option is correct. Means the heat generation time and the dissipation
Yes.
time means determines the welding time of the resistance welding. Means we need to provide that much heat to generate the welding.
But if you are applying more pressure, then well time should be lesser. Is it so?
Yes, no, pressure is only to consolidate the welding joint after melting.
Okay, so if you are applying more pressure,
Hmm.
that
And
nothing
temperature
related to
also
well.
depends on the heat generated. So heat is generated is written as I square R
I
heat.
square RT.
So this is current,
Yes,
this is resistance. So the heat generation will depend on the current and resistance.
not on the pressure. Huh?
Hmm.
Okay, okay.
Next question is the it is difficult to weld copper by resistance welding because of its
High thermal conductivity.
yes, because of the high thermal conductivity uh, n- the heat will dissipate easily. Means heat dissipation is high for the copper.
Yes, ma'am.
So next question is the when electrode force in resistance spot welding increases, so welding nugget diameter increases, the contact resistance decreases, heat generation does not significantly change, or bulk resistance increases.
So heat generation does not significantly change. Is it so?
No,
Because that is not related to pressure. Huh? Heat generation.
yes. So the question is on the when electrode
Electrode
force
force.
increases in spot welding, what happens?
So electrode force, does it mean pressure?
Yes, pressure.
And maybe weld negative diameter increases.
Yes, correct.
A or C?
Yes.
Why it is not C?
Heat generation does not significantly change. Yeah, means heat generation does not significant. Heat generation does not change. But yeah, in this question, the other option is not given. If it says that A or C is correct, then we can opt for that option. But the first option is more correct. This is
Okay.
also correct, but it is not the correct answer. Means the first option is also correct, na? So we cannot give two.
Okay.
So next question is the voltage needed in resistance welding does not depend on.
Composition.
No, the voltage depends on composition.
Okay. So length of weld,
Hmm.
area and thickness. Thickness of weld. Okay. Length of the um, thickness of weld क्या है हमें? What is this
No,
thickness?
this thickness of the weld means uh, this is the
Is
welding
it
depth, so this is the thickness, or
okay? The
the
thickness of
means the height of two plates. So this is thickness.
अच्छा प्लेट का thickness है. Okay.
Hmm.
मैम इसका तो कुछ आइडिया नहीं है अभी.
इसका करेक्ट ऑप्शन है इसमें एरिया. सो द वोल्टेज does not depend on the area of the weld. In all three it depends. With
Composition thickness और
increasing
length.
thickness and length, the voltage will increase. No, the voltage will decrease with increasing thickness. With decreasing thickness and length, the voltage increase. And with composition also, the voltage will vary.
And this area what?
Area of this welding, this area.
Nugget area.
Yes.
Okay.
Next question is a spot welding process basically depends upon.
Ohmic resistance.
No, in this question also the
Okay.
means the last option is correct. Correct means current only. Means if
I
it is
square
given
RD.
that more than two answer, then we can opt. But it is
No,
only
I
one
square.
answer. Yes, I
I
square.
square because of I square. Huh?
Yes, Q equals to I square
Okay.
RT. So current
I think
lines.
if ohmic resistance.
Yeah, ohmic
Okay.
resistance also comes, but for this question, the current is the uh, correct correct option.
Okay. Ma'am.
Okay. So
Hmm.
next
The
question
type
is the type of joint used in resistance spot welding is.
left welding.
Yes. Next question is the most brittle region in resistance spot weld is.
Mm, weld interface.
Yes, means the alloying element segregated that point. So that becomes
Yes,
brittle
ma'am.
region.
Yes, ma'am. Just now you have covered this part.
Mm. So next point question is
Same
seam
welding,
welding
I think.
is.
Multi-spot, continuous spot welding.
Yes,
B.
correct. And the next question is means I max in resistance spot welding is.
4 times of thickness. Current at which welding? Equal to 4 times. A option.
Hmm. Yeah, this also correct, but the in this question, the correct option is the means current at which expulsion of
Conversation.
melt occurs.
Okay, ma'am.
The next question is the post pulsing in resistance spot welding denotes means we first created the molten metal and the applied the
Okay.
force to form the welding joint. So this post pulsing is after the forming of welding joint. So in the enhanced weld cycle, we studied this post pulsing.
Yes, yes, yes. Ultrasonic vibration, tempering, post-weld conjunction, post-weld microstructure. Is it ultrasonic vibration?
No, we use tempering or quenching we do na. So in quenching, current is zero,
Yes, ma'am.
and but in tempering, we
Tempering, we
provide
have
the
to.
amount of current
So
to heat to provide the heat treatment.
this tempering current,
Yes.
after welding.
Hmm.
Okay.
So next question is then deterioration of copper electrodes live while welding galvanized steels is mainly due to
Diffusion of zinc to electrode surface.
yes, because the galvanized steel have zinc coating. Next question is the efficiency of submerged arc welding is higher than gas metal arc welding because
Number A option, convective and
yes,
radiation
heat
arc.
losses are minimized.
Yes.
Next is the shear strength of resistance spot welds increases with weld nugget diameter.
Well, the diameter, yes, ma'am. A, A
Means
option.
no, in this question, the all options are
All of
correct.
them wrong.
Mm. So with welding current, shear strength increases. With welding time also, it increases.
Oh,
So in this option, I mean, in this
all
question,
of
all the
them.
above is given, so we can take this. So have you enrolled for the exam?
Yes, ma'am. I have enrolled for this exam, ma'am.
Okay, then the
Actually, I couldn't appear for the exam last time.
means ये
So,
जो
though
assignment
I have, yes, ma'am, I have submitted all the assignment, but this time I'm not submitting the assignment.
why?
The assignment score will be at previously I have submitted, so
Okay,
that will be considered for my assignment.
okay, okay, fine.
And
So
this time I am just appearing for the exam.
okay, okay,
And,
okay. So
okay, so
then
thank you so much, ma'am.
okay,
Yeah,
thank you.
welcome.